Hey everybody. In our last video, Understanding Cut Parts, we covered how to create a new cut part in an empty product. And we reviewed the part properties interface, how origins, rotations work, and how to control the base point, machine point, and origins and rotations of a part. And today we're going to build on that. I'm building on what we know now about cut parts. So if you go back and you haven't watched that first video, I'll link that here and you can go back and watch the cut parts video. And then today what we're going to do is we're actually going to build on what we did in that last video, and we're going to make a product. And in this case, we're just going to make a simple base cabinet box. And so just as a reminder, the intention of this video series is to show how Microvellum works under the hood, so to speak. So what we're doing here is starting from scratch. And as we progress through this video series, we'll add things like parametric formulas, but really in the start, we want to start simple and just illustrate one thing at a time. So for those that are watching and maybe screaming at the screen, hey, you should put a formula there, we'll get there. So if you watched the last video, we made this part here. And so today what we want to do is I'm going to use that same product and build in on it. And we want to make something that looks like this. So I've put in just a regular open base cabinet. And so by the end of this video, we will have from scratch just a carcass with left, right sides, bottom, stretchers, nailers, and a back. And I think at the end, I'll give you a bonus in this and we'll put some associative datos on the back. And in the next video, we're going to start talking about sub-assemblies where we will build further on this and add doors and adjustable shelves inside using sub-assemblies. So just to get started, as I mentioned, I've got the product I had before. So the first thing I'm going to do is I'm going to go into the product prompts of this single part product. And I'm going to go ahead and put in a width, height, and a depth so that I have those to be able to reference and make my cabinet the right size. So I'm actually going to double click here, which is, if you don't know, in product prompts, if you have this type of prompt, you can actually double click and pick points for a measurement. And I'm just going to use the measurements from this cabinet I already have here as an example. So just as a reminder, I'm in a metric configuration. So what you're seeing here is metric measurements, but you can do all of this in imperial as well. So don't get hung up on the units here. Everything I'm going to show you works the same way. Okay, so I'm just going to put in width, height, and depth just so that we have those to reference in the part properties later. And so as you see, it actually gives me, so by default, Microvellum products are going to put in a little rectangle here for the 2D representation in plan view of my cabinet, which is going to match my width and depth that I just put in. Ignore where the part's sitting. We're going to fix all that. So now what I want to do is I'm going to go into my part properties of this. And so from last time, we have Jacob's part, and I'm going to rename that, and we're going to reclaim this. I'm going to make this my left side. Depending on where you are at in the world, you might call this a bulkhead. You might call it a lot of number of things, a gable. I'm going to just call it a left side. And so our quantity, still the same. I just need one of these. And our width though, so in this case, we want our width of the left side. This is the width we're going to use is the depth of the cabinet. So this is going to be your first taste of some formulas here. And there, in every Microvellum product, you have height, width, depth as defined names. So I'm just going to do equals depth and apply. And you see we'll get that same 560 that we put in before as our depth. Now our length, we're going to just ignore a couple things here about toe kick height, and we'll worry about that in a future video. So I'm just going to make the length with, remember, we're on our left side part, so I'm going to use my height here and just keep it simple. And that's all I'm going to worry about right now. I've already got an edge banding. I could go and pick a pointer and find my base open side edge, for example, or I could just do base carcass edge. And then my material name, and depending on where you're at, you probably have a pointer for base left side maybe, or base side. Let's see. Yep, I'm just going to pick base side. So again, what's picked there, we're not super worried about it. So let's just save and redraw and see what that does for me. So now I've got the right size, but it's not where I want it. So I actually want this part to move up here so that it's sitting in orientation with my cabinet where I want it. So I am going to go to my origin and rotation tab. So I'm still on my left side. I'm going to go origin rotation, and I want to move it forward by the width of the part. So to do that, I could do this a number of ways, but just to remember, we are working in our Y. So you can see here in my part window that I've got my X, Y, Z coordinate. I want to go, this is telling me Y is this way, and I want to move it in the Y. So I'm going to go to my Y origin, and I'm going to put equals, and I'm going forward, which in X, Y, Z coordinates, this is actually negative, is to come forward on the product. So I'm going to do equals negative depth. And I'm going to save and redraw, and you'll see it moves forward. Now, one last thing that might not be obvious, but I'm actually now to the left of my product by the thickness of my part. And so there's actually a couple of ways that we can do that. But the simplest thing is I'm going to use by changing my base point. And so right now I'm on a base point of 1, and you'll see that's the right face, right corner, and I want to shift to left corner. So I'm just going to change my base point from 1 to 2. And so you see now my base point, which is red, if you remember, switched. I'm not worried about my machine point right now, just my base point. So again, we're going to save and redraw. And so now we've got our left side sitting where we want it. My right side is very similar, so I'm just going to copy my left side to make my right side. So just by right-clicking, copying selected part, I get a copy of it. Now I'm going to pick the new one. I'm going to go back to the part name, and I'm going to change this because now I want to call this my right side. Everything else is the same as far as my size. My width is still the same. My length is still the same. My edge bending material are going to be the same. The only difference is now I know that I want this, because now this is just going to be a second part sitting on top of the first one. So I want to move this over here to be at the right side. So now I'm moving in the X direction. And so I'm going to go to my X origin, and I'm just going to put in equals width, because I want to shift this over by the width of my cabinet. And so we're going to save and redraw. And so now you'll notice I got it where I want, but I'm off by the thickness of my material again. So we want to reverse what we did before. And I want to now change my base point back to 1. So that gets the outside of my part, and we can double check that our width from outside of left side to outside of right side is 900, which is what we put in for the width of our cabinet. So what's next? Let's put in a bottom. So I am going to just copy this part, and I'm actually going to start with my left side because there's more of the origin that I can copy. So now, first thing I'm going to do is I'm going to change the name. I'm going to call this my bottom. I'm going to leave my width because now my width is still going to be the depth, but my length is going to be different now. So at base level, my length, I know I need to reference my width, but I know that I'm going to need to reduce it by the thickness of my sides. So the first thing I'm going to do is go to my length. I'm going to make it equals width. And something we can do here to make this parametric is I'm going to need to reduce it. I'm going to need to reference the thickness of my materials. And so as long as you're in a modern library within the last, I think, 5 years or so, there's actually in the M workbook, there's defined names. So because I'm using a pointer, there's also a thickness defined name for this pointer. What I'm going to do is I'm going to copy the pointer that I'm using for my sides. And now I'm going to go to my length, and I want to reduce this. So I'm going to subtract this, and I'm going to go underscore thickness. And so something else you can do is I can actually go to paste name, and I can go to look for material pointers, and I can find that same base side, and you'll see here's the defined name. So if you don't know, you're unsure about how to type that, again, you can always come back here and reference this. And I know my pointer was base side, so I'm going to go to base side thickness because that's going to give me the thickness, and I could enter that as well instead of just typing it like what I just did. Going to get the same result though. So I'm going to do width minus thickness times 2 for the left and right side. So that gives me my length. And now the only other thing we should have to do is go and change our origin and rotation. So you'll see here, I'm going to get still this part standing up, and I want to rotate it to lay down. And so we know that we want to rotate it around this the Y direction. So that is our rotation. We're going to try to go, and you'll notice we're already at -90. So I'm going to guess that if we change that to 0, so we went -90, I want to go back down. So let's try changing that to 0 and see what that does. And here's the thing about this is you can play with this until you get it to look right. All right. What you'll see is now we've got it laying down the way we want, but we're below where we want to be by the thickness, and we're off in X by the thickness of the left side. So there's two things we need to change. For the first one, I'm just going to change the base point to shift us up by the thickness of the material. So I'm going to change that back to 1. And then we need to change our X origin, and I need to reference that same side thickness again. I'm going to go back to paste name, material pointers, and I'm going to find that base side thickness. So as you see here, now we've got our bottom, which is sitting in the place we want it. So we can move on to our stretchers next. So I'm going to put my front stretcher first, which again, I can now copy my bottom. We're going to change our name to front stretcher. And if we think about what's different about this, our width is going to be different. And so the length will be the same. So the length is going to be the same, which is the inside width, but the width, most people will make these, let's say 4 inches or maybe 96 millimeters. And so I'm going to change the width. So I could hard code this, but it's likely in your library, you might have a parameter or global for this, for example. So I'm going to go look and just see. If I go to paste name, I want to look at my globals for stretcher. Let's use nailer width just as a placeholder. And you can use you can use a local variable, and again, you can hard code it, but just for reference here, I'm going to reference nailer width as something. So it's 100 millimeters, okay? Just close to 4 inches. The length again is the same. So now the only thing we're going to need to do is go up to origin and rotation, and we're going to need to shift it in Z this time up. And by how much, we are going to do equals height. And so we're going to save and redraw. And so you'll see we got it up there. And as has happened in each other part, we're just off by the thickness. So I'm going to change my base point again to 2. And that should get us where we want to be. So we've got our bottom, left, right side, front stretcher. Let's make our rear stretcher. This is all going to start to be very repetitive, but just to show you how simple it can be, we're going to copy that part. I'm going to change the name, rear stretcher. Width and length are going to be the same. Material, edge banding, we're going to leave. So now we just need to push it back. And this is where it gets a little trickier because we've got some more things to think about here. So we know we need to go back, but not all the way to the back. And so we've got some things we don't have defined yet. But just to keep things simple, let's push it back. And this is in Y. And let's just push it back to 0 for starting point. So let's see what that gives us. And so you'll see now we're off by the width of the part. So similar to changing it before, we can go and change the base point. And if you look here, we're at this corner and we want to now be at that corner. If I look here, I can see this is we're at base point 2. So if I change it to 4, that should move my part forward by the width. So you see it got us there. So I'm going to go and I'm going to put in my nailers next in my back. And then once we have those, we'll come back and push this forward because we'll have some more information to base that on. So let's copy our rear stretcher again and then use this to make our top nailer. And we're going to keep the width and length the same, but we need to rotate this down. What I'm going to do is I'm going to go to origin and rotation, and I am going to try and rotate around the x-axis. Let's see what this does to us. So we got the rotation right. We're just off by the thickness of the part again. So I'm going to come here and I'm going to change. And something you can always remember, base points, odds and even numbers face each other. So 1 and 2 go together, 3 and 4 go together, 5 and 6, 7 and 8. So I know I just want to change from face 6 to face 5. So I'm going to change it from 4 to 3. And you can see that here. And again, if I redraw this, you'll see we move by the thickness. So let's make our bottom nailer next. I'm going to copy the top nailer, rename it to a bottom nailer. Again, quantity, width, length are going to be the same. My material and edge banding, we just need to change our origin now in Z to be here. And so thinking a little bit ahead, we know we can go back down to 0, and then we're going to need to be up from 0 by the bottom thickness. So keeping things simple, I'm going to go to my Z. I'm going to go back down to 0, but we just want to be positive by bottom thickness. And if you remember, we've still got that same material thickness we referenced before. I can get that from a couple of places, but I'll do the same thing as I did before, and I'll do the paste name. So I'm going to go to my material pointers and find base side. And really, if I were being correct, I would be changing this to base bottom, actually. Let's try that, base bottom thickness. Now, to make that accurate, I should actually change my bottom material to base bottom. But so now we're at just 16 up. So let's see what this gives us. All right, so we're now down where we want to be, just off by the width of the part again. So that we can solve with the base point. And in this case, we are wanting to just move from here to here. So it's going to go from 3 to 1. All right, so we now have 2 nailers where we want them, front and rear stretchers. We need a back. So this is going to be a totally new, unique part that is going to be a different thickness. I'm going to use a 1/4 inch back that we're going to set up to dado in. So let's just add a new part from scratch so you guys can see how that works. So I'm going to name it as my back. And so we're going to have to create or use something to reference here. But if you imagine, we want to be width and height are our reference points, the cabinet width and height, but we don't want to be the full width or height because we want to dado into the sides and bottom. So first I'm going to start with my width. I'm going to be equals width. And then we're going to want to reduce that by the thickness of my sides first. So I'm going to come in by the thickness of the sides, and then I'm going to go back out by my dado depth. So I'm going to do plus paste name, and I'm going to go to my material pointers again. I'm going to find base side thickness times 2, because we've got 2 sides. So we're going to be, and I did this correct, I want to subtract that. And then we want to add back our dado depth, which I should have a global. So I'm going to just use dado depth for a global. And again, maybe you have a hard code value, but the concept here is to reference something that, and I'm going to do that again by 2 because we're doing it for each side. Our length, which in this case is going to be the height, it's going to be equals height. And similarly, I want to subtract, in this case, we're only going into the bottom. We're going to go fully to the top of the cabinet. So I just need to do bottom thickness, base bottom thickness. And then I'm going to add back my dado depth. So let's just, as a starting point, see where this gets us. Probably nothing, because I need to pick a material. So let's go and pick our back material. So we should be able to do base back, which we'll see is a 6mm white melamine. And then let's go to origin rotation. We have something there, so let's try and see. Okay, now that we have a material that's drawing and it's flat. So we need to rotate this up. And actually, I think rotate it sideways. All right, so let's start with our X rotation. What is that going to give us? So now we're up, but as you see, our width and length are transposed, it seems to be, which our width and length are good here. So we just need to rotate this. So now our width is correct, but we're below where we want to be. So let's try changing our base point. At this point, we're at 2. Let's change it down to 8. All right, so now we're looking better. But as you'll notice, we are off by an X. So we need to be pushed over to the right so that we're by the material thickness and then back into the part just by the dado depth. So we first need to change our X origin. And so I'm going to work my way to where I should be into the part by adding the left side thickness and then subtracting dado depth. So I'm going to go back to paste name again, base side thickness. And then again, we're going to subtract paste name global variable dado depth. So that is going to move us over an X. And I'll go to front view to make this more visual. So you see that's our back. And we look good in the X, I think. I'm going to take some measurements here. So we are into the part 6.35 on the left and 6.35 on the right. So we are symmetrical, but we need to go up now. Similarly, we need to go up by the bottom thickness and then back down by dado depth. So I'm going to do my Z origin equals paste name. And here I'm going to use base bottom thickness and then minus dado depth. Now we are flush at the top and we're sitting pretty here at the bottom. I'm going to go back to a southwest view so we can see everything. So now we're off in Y, so we need to come forward to be in front of the nailers. And so looking back at our nailers, first I'm going to go back and check my pointers. I'm going to change my nailers and find my nailer pointer, base nailer. Same for top nailer. And then now for my back, I can in Y reference the. So we're going to reference material pointers, base, nailer thickness. And again, in Y, we're actually coming forward, which in XYZ coordinates is negative Y. So let's see where that puts us. All right, so now let's go to a plan view. You'll see our back and our nailer are flush. So now we need to come forward by the thickness of my back. So one last time, we're going to add now, or subtract the base back, base back, thickness, where is base back? Looking like Microvellum's missing a defined name there, so let's use this. Oh, there it is, base back thickness. All right, ooh, let me do it right. I missed something. Minus material pointers, base back thickness. Okay, apply, save and redraw. Okay, so now we're moved. Okay, we're looking in the right place. So the last thing I need to do is I've got this rear stretcher that needs to come forward by nailer thickness and back thickness. So let's go back to our rear stretcher and in our Y form origin, and we actually can pull what we just did here for the nailer on the rear stretcher Y origin. It should be the same formula. And now we've got that sitting in front of it. So if you look, we now have a cabinet, a carcass. We've got sides, bottom, back, nailers, and stretchers. And we've built that from scratch. So what you've learned now is how ultimately cabinets work. And you can start to see that as we're going, we can use reference names and formulas to make this parametric. And because we did that, I can actually go back to my product prompts. And if I change this width from 900 to 800, for example, everything should change with it parametrically. So you can start to imagine how Microvellum builds their libraries and how you can build custom products now from scratch or reverse engineer existing products to understand how Microvellum works and make your own. So I told you at the end I was going to give you a bonus and I was going to add associative machining tokens to this back. Because as you probably are thinking, hey, this needs to be data, there needs to be machining there. And I'm going to do another video more detailed about this, but I'm going to give you this bonus here and we're going to add that real quick. So in part properties, we can go back to the back, or we can go to this machining tokens tab. I'm going to add machining. So what we want is we want associative dado, and I'm going to do associative dado with router in this case. You'll see it gives you a little image showing you what we're about to actually do as a reference point. And so I'm just going to click OK. And so then once we click on it, we have some options here to set things up. Lead in, lead out, and you get some instructions here. We're not going to worry about that. So I'm going to make the depth, and I'm going to reference that global we had before, dado depth. Dado thickness, I'm going to reference my part thickness, which is my back, base back thickness. Now, you'll probably notice there's clearances and extras you want to add to this that I'm not going to get into those details here. The important thing is the panel penetration has to match exactly how far, based on the origin, the part is going into it. And so we know that, again, is dado depth. So this is where you can run into issues, is if this parameter doesn't match the actual distance that things are going in. And this comes with 103. I may or may not have 103 as a tool in my tool file. So here's what's important, is that you probably go to your globals, and there's some default dado tools what I'm going to pick. And then let's just see what this gives us. All right, so I figured out what I was missing. So this panel penetration actually needs to be negative by the distance that your part is going into the side. So now that we have this one working, I should be able to copy this dado. So I'm on 1, which means I'm on edge 1. So we need one on the bottom, which will be edge 4, and one on the right, which is edge 2. So I now should just be able to copy this twice and just change this from dado 1 to dado 2 and to dado 4. And as you'll see now, we've got a dado on there on the side, got a dado on the right side, and a dado into the bottom. So in our next video, we're going to dive into sub-assemblies, understanding how they work and how we can use sub-assemblies to add doors and adjustable shelves inside of this cabinet.